The comparison instructions. This group of instructions are unique in that you can't look at the instructions and judge whether they're true or false by a color change on the screen. You actually have to read the values that are being compared based on the type of instruction. Typically, a greater than instruction is reading two memory locations, and then the instruction is true if A is greater than B. The less than instruction is true if A is less than B. But the color on the screen of the instruction, the look of the instruction, does not change whether it's true or false. So this begins a group of labs that use the comparison instructions, and the first two instructions that we're going to work with are the less than and the greater than. Not less than or greater than. That's another instruction. We're going to begin with the less than instruction and the greater than instruction. In this first lab, in the comparison instructions, you will see a format of logic that's going to be used for several of these labs. Rung 0 is a rung when true. A timer on instruction will instruct memory location data type T40 with a time base of 1 second to accumulate from 0 to 7. We don't have it reset because we can turn the rung to the false, or we can turn input 0 off, and then that will reset T40 to start over. We use a time base of 1 second so you can watch rungs 1 and 2 execute slow enough to see the behavior. Basically, rung 1 is a less than instruction. So when the accumulate source A is less than source B, 1, then output 0 will energize. When the accumulate of data type T40, timer data type T40, when the accumulate is greater than source B or 3, then output 1 will energize. In the bottom of this page, you see that we give you the opportunity to designate if output 0 is on or off and output 1 is on or off for each value 0 through 7 of the accumulate. So if you watch closely, and by the way, you can do this lab over and over again until you see the behavior. Once you see the behavior of these instructions, you won't forget. The only disadvantage of these instructions, they're unique in that the color of the instruction doesn't change. It doesn't become highlighted when it's true. You have to actually read the values to see if in a less than instruction, if A is less than B, then it's true. In a greater than instruction, if A is greater than B, then it's true. That's what's demonstrated here. Okay, so when the accumulate was equal to 0, output 0 was on and output 1 was off. When the timer accumulated until the accumulate was equal to 1, then output 0 is now off because in rung 1 the accumulate is no longer less than 1. It's equal to 1. Well, that instruction is exactly A less than B, nothing else. Okay, when the timer accumulated to 2, then both the outputs were still off. When it accumulated to 3, they were both still off because in rung 2, the accumulate is not greater than 3. It's equal to 3 right now, but it's not greater than 3. Once it accumulated to 4, now the accumulate is greater than 3, greater than 3, greater than 3, and at that point the timer was done and you would have to toggle input 0 off and back on again to start this process again. Now if you compare the results below with yours above, you will see a pattern here that we're going to reuse in the next lab. A circle is inclusive of that value. A line means continuous between those values. So output 0 was on when the accumulate was 0, but it was off for all the other values. Output 1 was off 0 through 3, but when you hit 4 it was on and would stay on as long as the accumulate was greater than 3. Now I show a circle to include 7 simply because the timer preset was 7. It just stops there. But if you increase the timer preset to 1,000, then that line that goes through 5 and 6 would continue on 7, 8, 9, 10 all the way up to 1,000. Okay, let's do this again. However, in the lab I had to change the values of source B. For the less than instruction, N70 used to be 1, now it's 3. So I have N70 and N71 both at 3. The reason that I'm using a integer for source B in both cases is so it's easy to change online. If they were constants, in other words, if you just typed in 3 for source B, you would have to go to the program mode to change it, or in the case of a MicroLogix 1000, 1200, 1500, you would have to go offline, change it, and then re-download. So to make this more palatable to not going back and forth between online and offline, we use a register for source B, which we can edit while the program is running. Okay, so same exercise as before. We're going to watch these two instructions and their effect on those two outputs as the timer increments or accumulates from 0 to 7. So when the accumulate is equal to 0, as before, 0 is on and 1 is off. When we increment to 1, 0 is still on and 1 is still off. When we increment to 2, same. Increment to 3, now they're both off. Because if you look at those two instructions, the accumulate is now at 3, which is not less than 3, nor greater than 3. It's equal to 3. So both those instructions are false. Both the outputs are off. And now when we allow it to continue to accumulate to 4, less than is false, greater than is going to be true, and stay true until we've hit 7. And again, if you increase the preset of timer data type T40, output 1 would stay on until the accumulate equaled the preset and still stay on until you reset that rung. Now, in the previous lab, I filled in this bottom section for you. I'm going to have you fill it in now. So if you look at the on and off states for the different values, then complete the pattern down below. So if you look, output 0 was on for values 0, 1, and 2, then off, whereas output 1 was on for values 4 until the timer was done timing, until the accumulate stopped, which means that the outputs were both off for the value of 3, because for a value of 3, neither the less than or the greater than were true. They were both false.